Okay, so I've been working on getting triggers into my game and basically getting that functionality that I already had in LEDWorks and putting it in EE. However, I wanted to do it a bit better. Now, often triggers are simply physics bodies um, that have, a fixed size or something, and it uses the engine's physics system to check if something is either touching it, colliding with it, or not colliding with it, without actually giving collision effects. Now, that wasn't quite enough for me. I wanted my triggers to be able to do a bit more than that. So I'll show you the different types of trigger events that I wanted to be able to recognize. So if you look here, I've got trig none, so nothing's triggering it. Trig start, something has just started triggering it. Trig on, something is continuously triggering it. And trig end, something has just stopped triggering it. Okay, so also on top of that, I've wanted it to be able to recognize different types of trigger things from the most common things that would happen. So for example, what this trigger will register as an actual collision, and that's trig unit, so a playable unit or character. Trig NPC, an NPC only, so maybe a door that only enemy NPCs can go through because it's their secret base or something, I don't know. Trig char, so that includes either an NPC or a playable unit. Trig object, which is things like this barrel here, or any kinematic object, or trig any, anything else that I haven't thought of, which includes all these. Trig any basically includes all of these different objects. And so that's that. Now, in LEDWorks, what I had was the triggers would live inside the object. So this gate, for example, would have a trigger sitting around, box around like that, and it would be a fixed size, and I wouldn't be able to change it. But I didn't want to do that in EE. I like how EE has its editor and how it works with object classes, so I decided, well, I'm going to make a trigger class that's standalone, which I've done, and here's the class and its functionality, and it inherits from an Esenthel game object, which allows me to essentially place the trigger into the scene, and then instead of that just being loaded as a mesh, it'll be loaded as a trigger. This is as this trigger class, and it's a bit of fake scripting, if you will. I'm actually still coding in C++, but it's acting as if it's a script. Same way you would use scripts, which I love because I hate scripts, but I love C++, and I love that functionality. So this, I can create object classes, parameters in the editor, and in this case I've created for the trigger, and basically they have just a couple of parameters active, whether the trigger starts out being open for business, an ID which has to be unique between all triggers, and what type of entity will trigger it. So in this case, either an NPC or a unit will trigger it. Now, if you don't understand how that works, in my level manager, how Esenthel works with that is that it takes these objects that you put into the world and it places them in containers depending on their type. Now I've specified their type. I've got a container here, an object container called triggers, and it holds trigger. And then I've specified in the Esenthel game world that, well, triggers, that container, everything put into triggers, and that class will have access to obj.trigger, which is this class type. So it might not make sense to you, but the point is that they're all connected. Now I can simply dynamically make shapes. So I've made a cube box, a meter square box, meter cylinder, and a meter sphere. And it doesn't matter that they're a meter now because they're not fixed. I can place them in the world now, and I'll just show you that. Place this trigger, drag and drop this trigger into the scene. It comes up in a box. I want to move it around, move it over there. I'll scale it up. I'll take a cylinder, check it over here. I can scale it up as well. Oops, wrong. Make it a bit flatter. And you can see I have access to these parameters, and I can override the default parameter. Because every ID needs to be unique, I need to change one of these IDs to a different value, so change that one to 1. And I shall just go into the scene and show you how it is. So these will have debugging enabled, so you can actually see the triggers. That's something I implemented myself. And I'll press play. Alright, we're in. Just start the game. Don't have a loading screen yet. Oh well. Now you can see my triggers have come up here, and at the moment they're red. Now I'll explain what that means. The triggers can be active, inactive, and they can be triggered or not triggered in this debug mode. And at the moment they're red, which means they're active, however they're not being triggered. If I put my character into the trigger, it'll go green, which means that trigger is being triggered. If I somehow deactivate the trigger by some means, like for example the gate might get locked and then the trigger will be inactive, then it'll go blue. So that's just the debugging. But you can see as I go into these triggers, they are going green, which means they're triggered. Nice and dynamically, just by placing the object in the scene, nice and smooth. So now I need to do a bit more. It's no good for them to just be triggered. They need to do something when they're triggered. So we're going to link up one of these triggers to the gate here. I'll just go back to the editor. Alright, so what I've done is I've created a class, which is a singleton class in the game, called a triggerverse. And each level will have a, well, there'll be only one triggerverse ever, and it will have all the triggers registered to it. So when a trigger is created, so I'll go to the trigger create function, it registers itself to the triggerverse through its singleton instance getter, I guess. It registers itself to the triggerverse. The triggerverse stores a map of triggers based on their ID when you register it. That's why they need to be unique IDs. And then anything can get a trigger using this by its ID using this function. And of course, because triggerverse is a singleton, it can be accessed anywhere. So now if I go to my gate class, my gate class has a pointer to a trigger. So it still has a trigger, however that trigger is not fixed to the gate. It gets its trigger from the triggerverse. So when it creates itself, what it does is it gets that trigger ID. So if you have a look at my gate parameter class, it has a parameter for trigger ID. So whatever is the relational trigger ID. In this case, it's 0. That's the default. However, in my level, let's have a look. The trigger ID is 3. I purposely put it to 3 because I didn't want you to see that these would open it up. So now we want it to trigger when it hits one of these triggers. So this trigger ID here is 0. Let's put the trigger ID of the gate to 0, and let's position this trigger nicely under the gate and make it more appropriately sized to trigger things that approach it. Move it around a bit. Alrighty. Trigger ID 0, just double checking. Trigger ID 0. Okay, I'll delete this. We don't need to show that anymore. And so now what the trigger, now that the gate has a instance of a pointer to its trigger, it can check that trigger and do stuff accordingly with the triggered function, and the triggered function will return int of the current trigger state, and that current trigger state will be one of these types. So the gate can now determine whether the trigger just started being triggered or the trigger just ended being triggered. And basically the gate uses trig start. When it gets trig start, it initiates opening the gate, and when it gets trig end, it initiates it closing the gate. That's just the very simplest functionality of my gate. It'll be much more detailed as a stateful object later, but that's not the point of this video. So now that we've set that up, let's go back into the scene and have a look what that's done. Okay, so now you can see our trigger is there. It's active but not being triggered, and our character is going to go loop-de-doop-de-doo, walk into the trigger, and you can see the gate opens and he can go on through. And of course it works with the pathfinding as well. The gate is actually dynamically changing the path mesh. I think I mentioned that, or rather explained it in depth in my last blog. Oops, I've lost something. So you can see how much more diverse this is, and it's, in a way, it's fake scripting, and I hope you enjoyed the video and maybe you got some insight on a good way to do triggers. I hope it's a good way. I think it works pretty well, and now I can link these triggers to anything, not just gates. I mean, I'm going to make heaps more things: elevators, escalators, traps. I'm keen to try it out. I'll catch you later. Hope you enjoyed the blog.